Hello explorers and welcome to another video. Today we are doing the Advent of Code puzzle. The Git repository is linked in the description below, and if you want to see all of my trials and tribulations, you can see the full recording as a member of this channel. So let's just jump right into it. Day 5. The expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates, but because the needed supplies are buried under many other crates, the crates need to be rearranged. The ship has a giant cargo crane capable of moving crates between stacks. To ensure that none of the crates get crushed or fall over, the crane operator will rearrange them in series of carefully planned steps. After the crates are rearranged, the desired crates will be at the top of each stack. The elves don't want to interrupt the crane operator during its deliberate procedure, but they forgot to ask her which crate will end up where. And they want to be ready to unload them as soon as possible so they can embark. They do, however, have a drawing of the starting stacks of crates and the rearrangement procedure, your puzzle input. For example, so we have the moves down here and we have the actual stacks up here. In this example, there are 3 stacks of crates. Stack 1 contains 2 crates. Crate Z is on the bottom and crate N on the top. Stack 2 contains 3 crates from bottom to top. They are crates M, C and D. And finally, stack 3 contains a single crate P. Then the rearrangement procedure is given. It's each step of the procedure. A quantity of crates is moved from one stack to a different stack. In the first step, the above arrangement procedure, 1 crate is moved from stack 2 to stack 1, resulting in this reconfiguration. In the second step, 3 crates are moved from stack 1 to 3. Crates are moved one at a time, so the first crate to be moved is D, ends up below the second and third crates. Okay, then both of the crates are moved from stack 2 to stack 1, again because crates are moved moved one at a time. Crate C ends up below crate M. Finally, 1 crate is moved from stack 1 to stack 2, and they also just need to just need to know which crate will end up on top of each stack. In this example, the top crates are C in stack 1, M in stack 2, and Z in stack 3. So you could combine these together and the elf's message is CMZ. After the rearrangement procedure completes, what crates ends up on top of each stack. So we have some stacking logic here that we need to figure out. So why not use stacks? That sounds like a great idea. And let's look at the input of day 5 here. So we have 9 here. A little bit more of stacking going on, but simple enough. Yeah. So we need some kind of logic to read this input, and then some kind of logic to figure out stacks. There we go. And these are at the right position. And that is on line 9 here. So I wonder if we want to hard code the actual placement. So this is on in 3. stack index line equal to 3. So let's read a list here first of string. Perhaps we can do a stack here also, or a deq of string stacks array deq like that. So line counts if line count is larger than stack index, so if it's less than stack index, we do like this. Otherwise, we will handle the stack index. Not really sure why they changed places. So there we go. And here we have stacks, stacks, description. Why didn't I copy the movements as well? Could be good to have. So there we go. Yes. So stacks. Let's give ourselves a little more space. So we have the stacks description, and then we have stacks, push, line. That's the only thing we do for the first things. Stack lines. And then we want to have a list of stacks. And let's call that an array list. So here we have all the stack lines, and then we need to figure out all the numbers. So number of stacks, and that's 3 in this case as well. So 4. Here we do a list of integer, and this should be the index stack x. So this is the index of the positioning of all the stacks. So we go in here and do I less than number of stacks, and here we will try to figure out where the different stack indexes are. So number of stacks plus 1. So here we have a line, and we need to find index of I, and this should be a string. And then we use stack index. Add to that. Let's do a system out here and see what we okay. There we go. So we have stack lines, we have 3 stack lines. And then we have this line, and we have stack indexes. And the indexes are 1, 5, 9. Okay. If stack index is empty, then we want to read these and continue. And then down here we will do something else. So now we want to read each line, so we take while stack lines pop. So as long as that is not null, and then we want to get stacks. So we first want to run this up here. Stacks, add new DQ. Array DQ. So now we have a bunch of these stacks that we add up here. And then here we want to do stack index get j stacks get j push, and then that one. Get the substring. So let's see what happens then. If stack index less than stack line length, then we do that. Else we can't. So now we should be able to do this. Remove first. Okay, so that will not return null. While not empty. Then we need to do a do, and then add the while loop down here. Now we can pop it. Now we do string char box ID like that. So if box ID is blank, if not box ID is blank. So now we will have all of them in there, hopefully. Yeah. So now we have the correct things in the right place. So now it's just a matter of so I think the whole thing here should only be done. No. There we go. So if stacks are empty, we do this thing. And then here we do a continue again. And if this line is blank, and we continue as well. So down here we should now have a new line ready with just a description on what to do. Yeah. So move. So let's see if we can solve this as one of you fine viewers used to do with regular expressions. Let's see if we can figure this one out. We would have a pattern, move pattern, compile, and this string would be move, and then we would have some kind of number here from, and then some kind of number again to some kind of number. And this would be the end of it. And this would be the start of it, right? Might have turned these two around, but matcher line, and then match if match find, then we will type out group 1, 2, and 3. So let's see. So we have a bunch of numbers here. Int number of, this is the number to move. And we parse the first group here. Move from is the second group. And then move to is the third group. Now we have our numbers. So now we go to 4 I int, let's have L 0 to number to move, and we will do that for move from +1 because we are not -1 because we are not 0 terminated. So stacks, we will get that, and then pop one of those, and then we will push that to move to. Like that. See how this looks down here. And the stacks looks like we expect them to. ZMZ is the ones on top. So I wonder now, this here is 9 with 9. So they are identical in the number of queues and the index. So we could do like that and just change this to 9 here. And then switch this over like this. So I was incorrect in my assumption here. There should be 9 and the stack index should be 8. There we go. So now we have all the stacks here. And they all have something in them. So let's do a for loop. Number of stacks. K plus plus. Stacks, get K, pop, system out, print. We only print it. So what happens then? We get that result. So that could be our puzzle input or our response. So let's see if that is the correct answer. Yes, you get a gold star. I get a gold star. Everybody gets a gold star. Nice. So we are using stacks here, which might make things much easier. It has become a lot of code here, but we pretty much figure out where this line is and how many stacks we have in order to just parse this file. We first go through and put a bunch of lines here, which is just the different lines in the input. And we push those to a stack because we want to build the stacks from the bottom up. And then we go through and figure out which the indexes is on each line for each of these stacks. And then we go through and increment through all of them and create queues for all the stacks. Go through and fetch the actual box ID and put that into a separate stack on that position. So we need to figure out where it actually should be and then put it into that position. And then we have a 0. We have something that starts on 0 and goes to 8, for instance, in this case, with all the stacks. And then the only thing we need to do is parse the move patterns and go through and do the actual moves. So number of moves, move from to, and fetch as many from that specific stack, pop them out, and then push them to the other stack. And the last part is just printing out what's on top of the stack. So we pop the first of each of them. So let's go over to the next one and see what that says. As you watch the crane operator expertly rearrange the crates, you notice that the process isn't following your prediction. Some mud has covering the writing on the side of the crane, and you quickly wipe it away. The crane isn't a crate mover 9000, it's a crate mover 9001. The crate mover 9001 is notable for many new and exciting features. Air conditioning, leather seats, an extra cup holder, and the ability to pick up and move multiple crates at once. Again, considering the example above, the crates begin in the same configuration. Moving a single crate from stack 2 to 1 behaves the same as before. However, the action of moving 3 crates from stack 1 to 3 means that those 3 moves crates stay in the same order, resulting in a new configuration. Retain their order, and finally you have a single crate moving from stack 1 to 2. So the new is MCD. Before your rearrangement process finish, they update to your simulation so the elves know where they should stand to be ready to unload the final supplies. After the rearrangement procedure completes, what crate ends up on top of the stack. Okay, so this is pretty much the same. The only thing we do now is that we have some kind of a buffer for these. So let's see here. We have the same kind of logic that we had before, but we want to keep all the pops and pushes. So I wonder if we have a pop multiple. We don't have that. So let's do like this. Very simple. Oh, we can do a decode. Do a DQ again. Array DQ. Push. Pop. Is that more correct? MZD. So now we have a routine that does the difference. So we create a new DQ, we push all of them to that DQ, and then pop them into the other one, so we can do multiple at once. So it's the same logic as before. We just do a little bit more of more stacking. So let's run this. Yeah, of course, we need to change these values. Number of stacks, 9, 8. There we go. And run it again. We get it totally different order. And we put that in. Yeah, you get a gold star. I get a gold star. Everybody gets a gold star. So we solved that one as well. And The only difference is that we pick up multiple. So we have one routine here where we push a bunch of crates into a new queue. So we get them in the right order, and then we pop them from that queue into the new stack that we want to put them in. So we take multiple out and put multiple in. So a lot of queue logic, but it just works. If you have the capabilities in your language to handle queues, then everything gets much easier to reason about and work around. So I hope that you found this interesting. I hope that you learned something today. If you solve this in a totally different way, please leave a comment in the comment section down below and add some code if you want. I read all comments and I really enjoy to see other solutions. If you like this video, give it a like, share it with your friends and colleagues. If you haven't subscribed yet, please do that. And I really hope to see you in the next video.